Now, after we obtain a significant F ratio, we're running into a problem because remember that the null hypothesis is that all of the groups are equal. So in a 3-group case, the null hypothesis is going to be that the mean of group 1 is equal to the mean of group 2 is equal to the mean of group 3. Now, if I obtain a significant F ratio as a test of this hypothesis, it doesn't tell me that both of these are false. It doesn't tell me which one of these are false. So I need to go in and look to see where there is an honestly significant difference. This is a Tukey's technique. Okay, and so Tukey's as a comparison procedure allows us to look at 2 means at a time. And any difference that exceeds this honestly significant difference, we perceive to be statistically significant. Remember that ANOVA produces an omnibus test of significance, and so post hoc tests are going to go in and discover where these differences are. Now, this procedure is detailed in section 8.5, but what I want you to remember is that a significant F value just tells us that at least one group is different than the rest. In order to identify which group is different, we have to use this procedure which we're calling Tukey's honestly significant difference test. And so this is found by taking our value that we get from the analysis of variance source table, the mean square within, and dividing it by the number of groups that I have. And then I take the square root of that quantity and multiply it by the quantity of Q that I find in table E in the appendix. And so by this procedure, we're able to disentangle an omnibus test to identify which specific means are different. So in the homework, for example, you're going to need to go in and identify a significant comparison, significant multiple comparisons. And so in order to do that, I encourage you to work with the material that's available to you in the Revel text, and in particular in section 8.5, where you'll go in and actually decompose a significant F value from an analysis of variance. The whole idea is we want to be able to go back to this general idea of if I have a null hypothesis that the mean of group 1 is equal to the mean of group 2 is equal to the mean of group 3, the Tukey's honestly significant test will be able to isolate. So for example, it's the comparison between group 1 and group 2 that's statistically significant, but the comparison with group 3 is not. Okay? Tukey's allows us to do that in a way that protects us from all of those multiple type 1 errors that are the problem when we just do multiple t-tests.